These are the frequently asked questions for pre-calculus for section 4.4 day 2. For number 41 and 42, it says, write the function y equals the negative sign of x as a phase shift of y equals the sign of x. And one of the things that we had talked about early in this chapter was how you could take sine and cosine, and you could actually write sine as a cosine graph by using phase shift and vice versa. And this is the same type of thinking where you want to think, okay, well, what do I know about sine and cosine graphs, and how is a change in phase going to make this different and match up? So let's go back to our originals and think about the fact that sine would normally start at 0 and then go high, axis, low, axis. And if we put a negative in front of that, remember what that does is nothing at the zeros, so these zeros stay exactly the same, but it reflects those highs and lows. So now, the green graph, I'm trying to figure out what could I do to that red graph to get that green graph, because it says write the function y equals the negative sign of x as a phase shift of y equals the sign of x. And I realize if I take the red graph and I slide it over, I would have exactly the graph that I needed. So now it's a matter of how far did I slide that over. I realize you of course don't have this ability on your paper, but that's a good visual to show you this is how we're going to make it move. And we need to move it from here to here. So those two match up. So we're asking, how far is it from 3 pi over 2 back to pi over 2? Well, that'll be 2 pi over 2, which is 1 pi. So we need a phase shift of 1 pi. And so we'll write that as y equals the sign of whatever x is plus pi to get that to match up. Now, if you're thinking about it in the other direction and saying, well, can't I put x minus pi? Well, as long as everything matches up, it doesn't make any difference. You know, there's a lot of different ways that we can write these. So let me see if I can get that red one to move again. Notice it'll work with a minus pi as well. It's the same thing. We're trying to make that low match up with the other low, and that's going to be by pi. So either way, you'll get there. And then for number 42, it says, what about cosine and sine? Okay, so we've got a negative cosine. How would we get that to be a sine? So let me get the green off of here. And let's go after that one. So there's our sine graph. All is good. And now along comes y equals negative cosine. So cosine usually starts at positive 1, but if it's negative, it's going to start low and then follow that wave pattern. All right, let me label this one. There we go. So now we take a look at that, and it says write that function as a phase shift of y equals sine of x. So again, what we want to do is figure out, well, how far would we need to move this? And I take my red graph. Let me pick that one. There we go. And I just move it over a little bit to the right. And I think, well, how far is that little bit? And just like we did with period, we can kind of use that maximum there, that top, to figure that out. Because from maximum to maximum is where we want to move this graph. And that's from pi to pi over 2. So pi minus pi over 2 is going to be 2 pi over 2 minus pi over 2. And that will give us pi over 2. So the shift for that one needs to be pi over 2. And that one was a shift to the right. So we would have y equals the sine of x minus pi over 2. Because remember, this is always x minus h. So if we're moving that to the right-hand side, it's actually going to be x minus in those parentheses. So that's a really good visual exercise. Again, you don't have to be exact with your graphs. You just need a sketch so that you can see how one would overlay on the other one and then use that to figure out your phase shift. Number 45 says, describe the transformations required to obtain the graph of the given function from a basic trigonometric graph. So for number 45, my basic trigonometric graph would be y equals cosine x. That would be my parent function. And I think, okay, what's really going on here to get it to look like this? Well, it would be y equals negative 2/3 cosine of 1/3 of x. And what we have to do is remember that x behaves the opposite of what we would normally think. And I need to start with that x. So I'm going to start right there. And I realize that there's a 1/3 in front of the x, but again, that's opposite of what we would normally think. A third of something we would think is a shrink, but it's not. Because remember, our formula for the period is 2 pi over that absolute value of b. So if b is 1/3, we're going to have to multiply by the reciprocal, which would actually be by 3. So it would take a horizontal stretch, factor of 3. That would be the first thing to deal with a. And for a, out in front, we see there are two pieces here. We have the negative and we have the 2/3. And this next step, you could use either one of those. I'm going to go ahead and put reflect over the x-axis first. And that's because this negative really was over here in front of the y. And remember, those reflections are always opposite of where we see them. So if there's a negative in front of the y, it means that we're reflecting over the x-axis. If there's a negative in with the x, then it's going to be a reflection over the y-axis. And then the 2/3, that's normal, and that's because that is really having to do with the output. And that's going to be a vertical compression. Factor of 2/3. So from the parent function, those are the three things we would need to do to make that new function y equals negative 2/3 cosine of x over 3. 50, describe the transformations required to obtain the graph of y sub 2 from the graph of y sub 1. So using this, what do we have to do to it mathematically to get it to be cosine of just x plus pi over 4? So we're really thinking, what are the numbers doing here that would make this happen? Well, first of all, the 2 disappeared, so we're going to have to deal with that, about how that's going to happen. And then secondly, I see the starting place on this graph is going to be a negative pi over 3, but the starting place on this graph is going to be negative pi over 4. So I'm going to need the difference between those two to know how far this is moving over. And just a quick visual on that will tell me that negative pi over 4 is actually closer to 0 than negative pi over 3. So I just need to know, if you take pi over 3 and you subtract pi over 4, how much has changed in that phase shift. And this would be 4 pi over 12 minus 3 pi over 12, which is going to be pi over 12. So it's going to move that graph pi over 2 units to the right. So for number 50, the first thing that we would say is shift pi over 12 units right. And then the 2. How do you get the 2 to be a 1? Well, you'd have to multiply it by 1/2. And if we multiply it by 1/2, that's a vertical compression. So we would need to apply a vertical compression factor of 1/2. So this is just looking at the math, just looking at the numbers. And you definitely could do this one visually too. It would just take a quick sketch for you to see, hey, this is where everything is going to end up for number 50. All right, number 52, what we have to do to the first one is figure out how to get rid of this 2. And to get rid of that 2, we would have to multiply what's taking place with the x's over there by 1/2, because we need it to be a 1. And remember, in the x position, when we are multiplying something by 1/2, that's actually going to be a horizontal stretch. So a horizontal stretch, but we do still want to think of that as a factor of 1/2, because we'd have to multiply by 1/2 to get rid of the 2. And then the 3 became a 2. So you say to yourself, okay, 3 times something gets me 2. What's that something? Well, it'd have to be 2/3. So we would have a vertical compression factor of 2/3. So those are the 2 pieces that would give us the numbers that we need in number 52. So again, you wouldn't have to use anything graphically if you didn't want to. It does help with the visuals, but this one would be really messy if you went ahead to do that. Then number 53 says, select the pair of functions that have identical graphs. And the good news on this one is that we've just got cosine there, so we can do this one graphically. So I'm just going to go ahead and put our standards on here. So if we have cosine, cosine starts high, remember Kahala, axis low, axis high, and they want to know which of these is going to match up with that. So take a look at the B and say, all right, that's sine. Well, sine generally starts at 0, but this one would be moved back, a negative pi over 2. So that one would start here and then go high, axis, low, axis. Well, there it is. No more looking around. And in fact, this is one right out of our notes that we had talked about, that you could use a phase shift in sine to match the cosine graph. Then for number 55, with this one, it's similar. What you want to do is just think of a quick sketch of what we already know. Still using our 2 pi divided by 4 for your period intervals. And then for A, remember that this would be a negative pi over 2 when we put that into our formula for x minus h, because minus a negative pi over 2 would be plus pi over 2. So we would be starting our sine graph back here at negative pi over 2, and that would be axis high, axis low, axis high. All right, so there's the graph that we want to match. And for B, for number 55, it says we need the negative cosine graph, but then we need to move it pi units, and this will be to the right by pi. Okay, so I go to pi, and I realize, well, cosine would normally start up at +1, but since they have this one negative, it would start down here, and then go to axis, and then high, and then low. By golly, look at that. Got lucky on both of these, and it was actually A and B that match up. So again, it's just a quick sketch. It's not anything that takes forever to do, but what we want to do is just start in on it and say, well, what do we know about this? Because we have the first graph, just think transformations. You know, what did they do? How do we get this to this new point? 56, what I went ahead and did with A was I just factored out the 2. And I can see this is a normal sine graph, but now what we have to remember is that this 2 is actually going to be a horizontal shrink. So it's going to shrink it by a factor of 1/2. And then our new starting place is going to be at negative pi over 8. So again, I'm just going to make a sketch of this. I'm not necessarily going to go full bore on it. But I want to keep in mind that instead of going all the way to 2 pi as an interval, Now we're only going to go to 1 pi. And so what it really does is it kind of shrinks all the math that I was doing before. But here's my sine, and then we would go axis high. Well, since it's been shrunk by the horizontal direction, not the vertical direction, I'm still going to go up to 1, a negative 1. But I have to think about how now this is what's going to be split into 4 pieces. So high, low, and there it is. So now I want to find another graph that would do that. Well, I take a look at B, and I see this is going to be y equals the cosine of 2 times x minus pi over 4, because again, if we factor the 2 out, it really would have the same effect as dividing by 2, which is going to be multiplying by 1/2. So pi over 2 times 1/2 is going to be pi over 4. So this was my little pi over 8, and I'm going to go to pi over 4 over here. And this one has a 2, which again means it's been horizontally shrunk. But at that negative pi over 4, I can see that we're going to have a little trouble here getting this to match up with that graph starting high with cosine. So I'm kind of throwing this one out, but it's multiple choice, so we can always come back to it and take a second look at it if things aren't working out well. B has cosine of 2x minus pi over 4, but again what we need to do is factor. And already, you know, pretty suspicious that things are going to work the way that we want it to here when we see that we have a negative pi over 8. Now, you might think, well, how's that going to work? The other one was plus pi over 8, and this one is a negative pi over 8. Well, that's because for C, that would mean what we're going to do is we're going to go over here to pi over 8. And again, I already have my intervals set half the size that they were before, and it's going to start high and then go low, and it follows right along. So that would be the one that would match it, would be C. And again, it doesn't take full-fledged graphs of any of them. It just takes an understanding that definitely we have a phase shift that will match sine to cosine. And we just need that same starting place once we think of it graphically about where it's going to go for sine versus cosine. So our sine graph had started here. And then our cosine matched up starting in this position. So that makes that one answer C.